Okay, here, let's quickly run through how to set up the experiment. It's very similar to the technique you used to set up the diffraction experiment. I don't think you'll have any problems. Oops. We can start by turning the laser on. As before, this helium neon laser beam produces a relatively weak beam, and it's completely safe unless you like direct it into your eyes and stare at it for a minute or two. That might produce damage, but otherwise, any reasonable care will avoid any hazard with this. We're going to set it up with two mirrors. So we'll want to set this up to get the beam to travel as before, at approximately constant height, approximately straight across a row of holes. I'm going to leave the crystal set up inside of the plexiglass box here, just for to make sure that there's no hazard. And so you'll have to arrange your optics to to work around that constraint. Okay. Once these are set up in approximately the right position, then we use these forks as before to lock them in place. And then we lock them in place by screwing these into the table. And once it's set, you can still make adjustments by using the fine adjusters on the back of the mirror mounts. Okay, what have I just done here? Okay. So in this case, for example, I've set this up, and then I can set up the beam. I'd like to arrange, to begin with, the beam so that it will go, that it'll hit the crystal and proceed through it without the lens, okay? Then later we'll put the lens in and make adjustments around that. Once the beam has gone through the crystal, we can place the detector somewhere out here. And we'd like the beam to be at the correct height to hit the detector. If it's not, you'll have to do some careful adjustment to get the beam to go both through the crystal and hit the detector at the right height. But you can do that in the following way. You'll use both mirror adjusters. You'll adjust the first one to get the beam at the right height here, and then adjust the second one to get the beam at the right height there. And then you'll go back and do that again. After several iterations, the beam should hit both points at the correct height. It's kind of an iterative solution, okay? Once that's set up now, we can place the lens in the beam path. This lens is a 300 millimeter focal length lens. So it should be positioned about 300 millimeters in front of the crystal, okay? But the main thing is we'd like to get the light to, oops, little problem there. We'd like to get the light to focus on the crystal. There we are. Okay, nobody's been killed, that's good. So that's the goal, okay? And then when you put the lens into the system, you'd like to position it so that as closely as possible, it doesn't deflect the beam from the beam direction before you had the lens in the crystal. If the lens doesn't deflect the crystal, that means that the beam is going right through the center of the lens, which is the optimal condition. And then this would be locked down with a fork as well. Okay. The last thing to put in place are the polarizers. You want one polarizer placed in front that will be polarized in the same direction as the laser. Okay. So the transmission is maximum. And then the other polarizer should be placed behind, and it should be set 90 degrees away from the first polarizer. Okay. Now, if there were no crystal in between them, you would find that that combination completely blocks the beam. You may find that that doesn't completely block the beam in this case, even when there's no light, when there's no electric field applied to the crystal. That's fine, don't worry about it. What's happening is, takes a little explanation, but it's just this. Mechanical stress on the crystal acts just like electric fields do. And although there's no electric field present now, there might be some mechanical stress on the crystal. And so that may be sort of like an offset. It's going to act like an offset in electric field. Okay. In any event, you'll see that it's not particularly important. Finally, when the detector is set, also locked into place, then you can connect it to the digital voltmeter, and you can also connect the amplified silicon diode to the power source here. Okay. There's also a switch on the back. It should be switched on, off, on, and then you should be all ready to go. So I think it should work great. I don't think you'll have any problems. This is an experiment where you don't need the computer to do any data acquisition. You can actually write down numbers in a lab book or on a notepad and then enter them into the computer to make a graph afterwards. One more hint before I let you go. The silicon photodiode detects any visible light. It'll detect a laser, but the room is also full of light from outside right now. So that would produce a big offset in the signal that you measure. So my advice to you is to close the shades before you start. Okay. And when you're ready to do measurements, you might darken the room. If that's not possible, or if that's not working out for you, we have other ways of solving that problem. Sorry. We have other ways of solving that problem, and we can talk about that. But I think just closing the shades and darkening the room will work just fine. Okay, I'm going to stop here. Sorry about the camera jumping around, and good luck with the